All right, next question. Looks like we have some download upload speeds for a particular country. So let's take a look at those. More importantly, let's open these in StatCrunch. Let's get rid of that. And let me get this where it makes sense. All right. So it looks like starting out, we need the mean and the median. So let's grab those. So I want for both, and I want to get the mean and the median. All right, so the mean download is 14. What do we need to go to? Two places, so 14.31. And the mean up is 8.03. All right, median download is 11.8. And median upload 6.5. All right, now we get into the variance, standard deviation range, and so on. So I'm going to go up to edit. I'm going to change this stuff. And this time I want the variance. I want the standard deviation. And I want the range. And I want the coefficient of variation. I tell you, I have never reported the coefficient of variation in any study I've been involved in. To date, I've served on 15 doctoral advisory committees, and I think it's 109. Served as a master's thesis advisor 109 times. I've never reported that, so that's a new one. Well, anyway, variance 52.36. Variance for down is 14.74. Standard deviation for down 7.24. Up 3.84. The range is 20.8. Gosh, this is tedious work, isn't it? Always afraid you're going to make a typo. It's easy, but it's just well, there you go. So easy to make a silly mistake. Coefficient of variation is 50.56. And for the upload, it is 47.80. So a little trickery there on rounding. All right, so based on the mean and the median, remember when the mean is greater than the median, which is the case in both the upload and download, then we have a right skewed distribution. So we will say that the upload speed is right skewed, and we'll say that the download speed is right skewed. Again, by definition of the mean being greater than the median indicates that. So the average download speed is 14.31. The average upload is 8.03. The difference between the fastest and lowest download speed so that's going to be the range. So that's 20.8. And of the upload, the range is going to be 10.6. So the download speed is Okay, so we're talking about variation, so we need to go to the standard deviation. So the standard deviation for download is higher, so there's more variation. So the download speed is more variable than the upload speed. And then we get into most of the download and upload speeds are in the, well, if you think about it, let me show what, all right, I don't need this anymore. We have a positively skewed distribution. It's going to look something like this. So most of the scores are in the lower portion. So that should be it. All right, more mean median stuff. All right, so open in StatCrunch. Again, double check that it's the variable name and it didn't put one of the values up there, which is really goofy. So I need the mean, median, and mode. All right, so the mean is 38. The median is 40.5. And the modes are, well, it really doesn't give us that, does it? It just says there are multiple modes. So what might be helpful in um, finding the mode is to sort these from smallest to largest. So it looks like a 9 and a 21 and a 44. Well, 44 is repeated 3 times. And 53 is repeated 3 times. So I'm going to say the mode are 44 and 53. Calculate the variance. All right, so let's do that. We're going to need the z-scores as well. Okay. Wow, this is a crazy problem. So standard deviation, range, coefficient of variation, and z-scores. All right, so let's calculate these first. So the variance is 353.24. Standard deviation is 18.79. The range is 71. And the coefficient of variation is 49.46. All right, going to have to do the z-scores. A bit redundant, but I don't think it's that bad to review this. So if we go to data, go to compute, go to expression, let's build the expression. So I want to take the variable minus the mean, which is 36, divided by the standard deviation, which is 18.79. Click OK. Give the column a name. And, oh wow, this is going to be so bad. Okay. So 31, negative 2.6. Negative 2.7. Negative 0.27. 21 is negative 0.80. 59 is 1.22. 29, this is overkill, but negative 0.37. 1.44. 0.43. Negative 0.11. And 0.90. If I got through there without a typo, it would be a miracle. Yeah, one of them's wrong. All right, so 31, negative 0.27, 21, negative 0.80, 59, 1.22, 29, negative 0.37, 9, negative 1.44, 44.43, 34, negative 0.11, 53.90. I don't know where it's wrong. Well, this might be actually a good learning experience. The standard deviation, actually, if we go variable 1 and just go to standard deviation, we actually get 18.6 or 794629. Now let's just double check and make sure that we get we have the mean out correctly. So it's 38. So let's rebuild our expression. So that's the problem. Had a typo. That should be 38. And let's just go ahead and put in 46. See, that's the great thing about being in class. You guys would have screamed and yelled at me and said, Dr. Darbo, that's wrong. So let's get rid of this. All right, fun stuff. 31.37. 21.90. 59, 1.12. 29.48. Gosh, this is annoying. 9, negative 1.54. 44 is 0.32. And 34.21 negative. And 53 is 0.80. Goodness. All right. 21. See if I can get through this without saying anything. I really have no idea why they require us to put in all of these. Because if we can enter the answer for a couple of them, then it's clear that we know what's going on. All right, hang with me. All right, finally. Are there any outliers? So when I scan through here, I don't see any outliers greater than 3 or less than -3. Uh, are the data skewed? Well, we look at the mean and the median. So the mean is less than the median, so we have a negatively skewed or a left skewed distribution. So based on, okay, so the average market penetration is 38%, and half the countries have penetrations greater than or equal to, so we need the median, 40.5. The average scatter of the amount around the mean, that'd be the standard deviation. The difference between the highest and the lowest, that would be the range. All right, goodness, that was crazy. All right, compute the quartiles. So let's open in StatCrunch. Again, make sure that the variable name is there and not one of the data points. So we need the first quartile. So we need Q1, Q3, and IQR, or we need the 5-number summary. So let's do it. All right, should give us everything we need. So the first quartile is uh, 6. Third quartile is 11. IQR is 5. 5-number summary, smallest 5, 6, 9, 11, and the highest value is 17. All right, let's look at the box plots. So we need the lowest value to be at 5. We need the median to be at 9, so this one doesn't work. So the lowest at 5, the median needs to be at 9. The highest value needs to be at 17. Q3 needs to be at 11. And Q1 needs to be at 6. So that is our choice. What is the shape of the data? Well, since this is the distribution we have focused on, in a previous video, I said if this right whisker is longer than the left whisker, then we have a right skewed distribution. All right, question 5. Use the accompanying find the quartile. So let's go for it. So Q1, Q3. All right, so Q1 is 26. 55, and 29. 5-number summary, we need the lowest value and the highest value. So I know I can go ahead and put in 26 and 55 there. So let's grab the other stuff. So the min is 7, max is 80. In the middle, the median 41.5. All right, box plot. So we need a shape that corresponds. So it looks like the bottom number needs to be 7. The median needs to be 41.5. Top number needs to be just below 80. This is a tough one. I'll tell you what I'm going to do. I'm going to cheat a little bit. I'm going to grab a box plot. And I'm going to, yeah, let's go that. Draw horizontally. So the box plot that looks like corresponds, looks like to me it's probably A. Describe the shape of the data. Notice that the left whisker and the right whisker are about the same, so the data are symmetric because the left tail is roughly the same as the right tail. All right, gang, looks like it's the final question. This has been kind of crazy. So here's the data. We have 1-year CD, 5-year CD. So let's open it in StatCrunch. So we need the 1-year CD. I have a feeling I'm going to need it for all. So I'm going to just go ahead and choose both of these and go ahead and get Q1 and Q3. All right, so Q1 for the 1 year is 2.82 and 3.94. The IQR is, I'm just going to use my calculator. So for 1 year is 3.94 minus 2.82. I've been on this so long, I've lost my voice. So the IQR is 1.12. In case you're playing along over here, that's all I did. So 3.58 and 4.69. IQR looks like it's 1.14. All right, 4.69 minus 3.58, 1.11. List the 5-number summary. Okay. So let's go for it. So I need the min, the max, Q1, Q3, and the median. So for the 5-number summary for the 1-year CD, 2.47, 2.82, 2.97, 3.94, and 4.82. 5-number summary, 3.47, 3.58, 3.75, 4.69, 4.89. Construct a box plot for the 1 year. All right, let's do it. These are horizontals. Let's do that. And we need a longer bar to the right. So clearly it's either going to be B or C. And we need the lowest to be at 2.47. So looks like to me it should be C. Describe the shape of the box plot. So it's going to be right skewed because the right tail is longer. Which of the following is for 5-year CD? So the one that seems to look the most, so the bottom is 3.47, and the mean is the median is 3.75. So unless they've done something really goofy with their labeling, that should be correct. The box plot is relatively symmetric. Okay, they got tricky on us here, right? So what's happened because see this bar and this bar, I knew they were going to do that. This bar and this bar are about the same, but because this bar is to the left, so much to the left to the center of the distribution, then we know we have a right skewed distribution. So I got sloppy there, and I'm not going to go back through all this because of one question. All right, so I will just take less points on this. I think I'll squeeze through and pass the class. What do you think? But yeah, I got sloppy there. This one would be symmetric. This one would not be symmetric. This is not symmetric because that median is not smack dab in the center. All right, gang. That's all I got. Take care.